All right, so in today's video, I want to go over subnetting and kind of more of an introduction to subnetting using a real world example of being able to build four separate networks using uh, specifically one subnetwork. Well, actually, one network, but we'll actually subnet that out to be four separate networks. And how we'll do that is using an RFC 1918 address, which, if you aren't familiar, we'll get into that as well. So, if you're in IT or you're in some type of tech field or you use computers or any type of technology, a lot of things, well, basically everything revolves around some form of an IP address. And in order to talk to devices outside of your network or on your network, you need an IP address to be able to communicate amongst each other or be able to route out to the internet, all sorts of things. So that kind of coincides with what we're going to talk about today and basically how we can set this up using this simple network here. So, if you're familiar with subnetting, this might be kind of just generic, but basically, there's three classes that you'll usually use the most, and that's class A, B, and C. Now, there's D and E, but we won't get into those there. But basically, I've put some notes down here, so let me bring these up. So, our class A network is everything in the first octet value 0 to 126. Class B, 128 to 191, and Class C, 192 to 2233. Now, if you're in a corporate network, you're only going to be able to use a portion of that. So the addresses that you're probably more familiar with seeing is anything in like the range 10.0.0.0/8. So that's going to give you anything in the range 10.0.0.0 all the way up to 10.255.255.255. And that's your class A network. And that's part of the RFC 1918 addresses that are allocated to be used privately because these cannot route out to the internet. And that allows you to be able to utilize these across your network freely. Now, if you are in a scenario where you are joining a network or you do some type of merger and acquisition, you could run into the case where you're using the same networking space to actually be able to communicate. So that can cause some problems, and you might have to get into things like natting and some more complex stuff that we won't kind of go into today. But so then for our class C addresses, you're going to look in anything in the 172.12 actually 16.0.0, and then this is going to be /12. So that's going to give you anything from, so basically, you're probably wondering what's this /8 mean or what's this /12 mean. So that's going to be like your subnet mask. And this is just insider notation. So what we're going to do, just to make this simple, a /8 is basically anything. So your 255.0.0.0. And this is basically based off of your the amount of bits that are used to create that cider notation. So to get into how this is set up, there's four octets, and how that is determined is by zero or ones. So 255 means that everything was basically utilized as ones. So 255 is basically 1.1.1 or 111.111. So 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8. And then the rest of these were zeros. Dot zero dot zero dot zero. You're probably wondering like, well, what's that? What's how do you know that that is 255? Well, basically, it's everything added up in that octet. So 128, 64, 32, 16, 8, 4, 2, 1. So if you open up a calculator here, so 128 plus 64 plus 32 plus 16 plus 8, 4, 2, 1. 255. So when you see like /8, that means 8 bits was used. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 bits that was used. So you have to add all those up, and that'll give you 255. And so as you can see, that goes there. And then let's actually copy this and bring this down here. So 172.16.0/12. So 12. So we got 8. So we got to keep counting. So we got 8. And then let's see, 9, 10, 11, 12. And then 0, 0, 0, 0. And then these are zeros as well, but I just made them .0.0. So let's actually just go ahead and add these. So 1, 2, 3, 4, 5, 6, 7. That's 8. 1, 2, 3. All right. And you basically can go. So you got 128, 64, 32, 16, 8, 4, 2, 1. Now you can basically do the same thing here. So we got 128, 64, 32, 16. So we use basically 4 bits there. So if we add that up, so we got 128 plus 16 or 64 plus 32 plus 16. So 240. So this would be, let's go ahead and take this, and so that's going to be 255.240.0.0. And that means we get any addresses ranging. So basically, whenever you have, this is going to be determined like the networks. So this last bit here. So now we can say, okay, we got 16. So it's 0. So 16. Then that means the next network has to be 172.32.0.0/12. So you can basically use any addresses in the 172.16.0.0 all the way to, let's take this out, 172.31.255.255. So anything in that range can be used inside of a private network. So now for the class C addresses, you have basically a /16. So anything in the 192.168.0.0 range will be 255.255.0.0. And as you can see, the 255 just means that this stays the same. Nothing changes there, nothing changes there. And then 0 means that we can add host bits in these and subnet bits in these 2 octets here. So that means we can use anything going from 192.168.0.0 all the way to 192.168.255.255. And this is where you'll see like a lot of networks particularly use their networks there, because you get, it's kind of standard in a lot of like tech appliances and things like that. 10.0s you'll see in like big corporate networks, because you get a lot of hosts and networks that you can create, just because you get so many octets that you can kind of, subdivide your networks into. Now, I'm not going to get too deep into like, the granular levels of like, VLSM and all those other type of things you can kind of do, like breaking down or subdividing subnets. So like, say if you have a /24, you can further break that down into like 2/25s or 4/26s or something like that. So you can basically keep going down, building more networks from an existing network that's allocated to like, say, like a building of some sort. So what we're going to do in this example though is, and if you have more questions, I can go deeper. Just drop me a comment down below in the comments and I can answer any questions you have. I know there's a whole slew of topics out there on subnetting. Hopefully you kind of get the gist of what's going on here. But basically, we're just focusing. If you kind of Google RFC 1918, it gives you more in depth on basically what's allowed. So I'm going to take a address out of this 192.168.0.0 range, and I'm going to use 192.168.1.0, and I'm going to do a /24. Now this /24 is basically saying, okay, I'm keeping everything here the same. This is going to be my network, and I have everything to work with in this last octet. So I can further divide it, subdivide it into multiple networks, depending on how I want. I can use it as one large network. So that's what I'm going to use for my environment here. So I'm going to copy, just give me some room here. So what I have is I have 4 PCs here. And each PC right now is currently sitting on one flat network. But you know what? I want this to be segmented off from, like, I want, say, like, this could be HR, this could be finance, this could be IT, this could be legal or whatever. It could be plants, manufacturing machines, whatever we want it to be, POS systems. So I'm going to take this network here and I'm going to subdivide this into smaller chunks. Now, this is also still, so I always like to take this little blurb here and copy it down. So if you look at this here, if we're doing a /24, that means you get one big network. And you can only base your host off of what this allows you to get here. Now you can do more. You can go into 256, 512, but we're only going to focus on the last subnet bit here, because as you start getting further back, the networks start getting bigger. The amount of hosts you can use gets bigger when you get into bigger networks. So what I'm going to do is I want 4 networks with, well, first of all, it just depends. So some engineers, they might get a new building that they need set up. And the building could be, say, hey, we need to allow 50, we're going to need about 50 people to access this network. Okay. So with that being said, in order to be able to get 50 people on the network, we're going to need this to be a /64. But let's say, you know what, we don't need 50, we need 50 total, but there'll be only, say, 10 people on each network. So 10 with, like, a little room to grow. So that means we only need, say, 10 hosts here, 10 hosts here, 10 there, 10 there. Okay, so now we can look at our chart here. And I know it's tough, I'm using this in Notepad, but basically I can do a /16 and I can get 16, and there's going to be 2 less network IP addresses. So you're only going to get 14. So I'm going to get 2 less IP addresses because one IP is going to be for the network address. And then you got the last IP address, which is going to be for the subnet or the broadcast address. So with that, we're going to need, so that's a 24, 25, 26, 27, 28. So we're going to need a /28. So what that's going to give me is, so this is going to be the main network, but then let's get 192.168.1.0/28. That's going to be, let's say, IT. So that means we got to go from 0 to then 16. So then 192.168.1.16/28. 192.168.1.32/28, and then 192.168.1, and then 16 plus 32 is 48/28. So as you can see here, we got 4 networks here now. So dash, and this is going to be HR. For no rhyme or reason, let's say legal, and this could be POS systems or whatever. So now we got four networks here, and this four networks is determined by, this is basically backwards. So how this goes is this is your how many subnet or hosts you can have. But if you want to know how many networks you can have, you can basically go backwards and say, okay, this will give you 2. This will give you 4. This will give you 8, 16, and then this will give you 32, and then 64, and then let's say then 128. So if you do a /25, you can get 2 networks of 125. So you can get anything from 0 to 127, and then 128 to 255. Because then if you do 256, it takes you into the next network. So you'd have to do a 192.168.2.0 / whatever you want to use after that. So that just kind of, you just kind of count backwards basically. Instead of going forward to get your networks, you go to small to large to get your hosts. You go large to small. So now we're going to go into our switch here and basically set this up to kind of show you a way to subdivide your networks into different VLANs. And then you can take that and also do some cool things as far as like routing between different VLANs, ACLs, and stuff like that. So as we look on the switch here, I do show VLAN brief. So we got one VLAN and everything's sitting in it. So it's one big flat network. So what I want to do is I want to just do T and then VLAN. We're going to do a VLAN 1. So we're going to do 10. So this is going to be VLAN 10, 20. This is going to be 30. And this is going to be 40. So let's see, VLAN 10, and then name H or IT, VLAN 20, name HR, VLAN 30, name legal, and VLAN 40, name POS. So if I exit out of here, show VLAN brief. So we got our VLANs there. And basically those are just, VLANs. You can stick devices in there. They basically can talk to other devices in their VLAN. They won't be able to communicate outside of that. And the reason being is because there's no interface for those to route across. So if we do a show interface brief, show. We don't have any VLAN for interfaces for those VLANs. So to do that, so if we want those to be able to communicate across from each other, we can basically say conf T interface VLAN 10 IP address 192.168. What do we have? 1.0, so that'll be 1.1, then 255.255.240. And the 240 again is because we're adding the 128, 64, 32, 16 because it's 28 subnet bits that are being used to create this subnet. And so now we can just do enter there. And then we can basically just go up and do VLAN 20. And then just change up. Change these to be it. VLAN 30. Let's let that come up. Or it's down because we don't got nothing in it. So VLAN 30 is going to be 3.1. And then VLAN 40. And then let's change that one there. So now we got our interfaces. So show, let's do a show IP interface brief. So VLAN 10, 20, 30, 40. So now what we'll do is we'll find out where are these actually sitting at. So we'll do PC 2, 3, 4, 5, just down the line. So 0, 0, 0, 1, 0, 2, 0, 3. So let's go ahead and put those in their respective VLANs. So VLAN conf t interface gigabit 0/0 switch port access VLAN 10, and then let's just go 1 VLAN 20, and then 2 VLAN 30, and then 3 VLAN 40. And do show VLAN brief. So as you see, we got all 3 of our ports now in their respective VLANs, and we got interfaces for those. So do show IP interface. Oh, we need to bring those up. So let's go interface VLAN 10, no shut. No shut on that one. It's just down the line. So then 40. So now if we go back and we look at our interfaces, we should have everything up. So now everything's up. So now we need to assign IP addresses to these devices. So if we go to, now if we go to these PCs, and these are just kind of just emulated PCs using EVNG. So sometimes I forget how to set the IP address on these here. So let's see, this is IP, so IP address mask gateway. Okay, so IP 192.168.1. Let's say give it an IP address of .5. We'll give all of them a .5, then /28, and then we want to give it the gateway, which is going to be 192.168.1.1, and enter. Now I should be able to ping that gateway 168.1.1. And there we go. Now if I try and ping, let's see if I can ping 2.1. Yes. We don't have anything blocking these ACLs going across, so we should be able to get to all of those. There. Now, but you can see now I can't get to, let's do like a 3.5. There's nothing there yet. So let's just go down the line and configure those different PCs. But you know what? What I will do is, let's actually go, so IP, what is it? Okay, IP 10 or 192.168.2.5/28, and then 1.1. Oh, 2.1. Same here. IP address 192.168. And the great thing about this is you can actually, apply this to a lot of different subnetting and networking techniques that you might come across in your journey as you're either studying or building out, your networks or troubleshooting different things across your home network or work network. So 192.168.1.2, or actually 3. 255/28. And then our last one here was this one 4.5/28 68.4.1. All right, so we got all those configured. Now, if I was to ping this one, I should be able to now. So that works. So now we're able to communicate across the VLAN, no problem. Across the VLAN interface, no problem. And one way to actually know that that is working, if I go into interface gigabit or interface VLAN 30, and I do a shutdown on that, and then I go back here. Where was I at here? PC2, and I try to ping this again, it's going to fail. Destination host unreachable. So we know that that's being used by that VLAN interface. And if I do a show MAC, I think it's address table. Yeah, let me go back here. So you can see the different MAC addresses that are being identified on this switch. So it knows where to forward those packets to when it comes in through those interfaces. So VLAN 10, you forward out port 00. VLAN 20, forward out port 01. VLAN 30, forward out port 02, and then 03. So that's one way to kind of troubleshoot finding MAC addresses or where devices sit on a port, on a switch, whenever you're trying to find issues that come across on your network and you don't know where these devices are. So you can do like some MAC address lookups and stuff like that. So that's it there. So basically we have we had a flat network, but then we subdivided it into 4 separate subnets, which then basically are just being utilizing their sub interfaces or their VLAN interfaces to route across. And you can do some cool stuff then later on if you want to, as far as doing some ACLs to block access from one network to another. So if you don't want one network to talk to another, then you can kind of put in some rules and stuff like that. So I'll do a video on that same configuration there on my next video. We'll talk about how to then start to do like some ACLs to then prevent cross VLAN communication. If you want to kind of bring in some more security and things like that. So again, check out my blog, letmetechyou.com. Like and subscribe. If you have any questions in regards to today's video, drop me a comment down below and I'll be sure to get back with you. Again, thanks for tuning in. I hope to see you next time.